Welcome to Lesson 5. Now we are going to compare output powers of different technologies presented on the slide to a blue LED power. By the way, the blue LED that you saw in the previous lesson, if you bring it close to your eye and stare at, it can blind you for a long time or permanently by damaging your eye retina. Don't try to look at the LED for too long at a short distance, and don't bring it close to your eyes. The first technology that we are going to compare is the Bluetooth device, which is typically used in wireless headphones, earphones, and headsets. The typical output power of a Bluetooth headset, which ranges from 0.0005 to 0.0025 watts, is significantly lower compared to the power of a blue LED. So the output power of a blue headset is about 100 times less than the blue LED. Next, we are going to compare our blue LED output power to a Wi-Fi transmitter. Wi-Fi transmitter power in a home router typically ranges from 0.05 to 0.1 watts, which can be similar to the power of a blue LED or even double that amount. Wi-Fi radiation from a home router is generally about double the power of the blue LED and similar to the radiation emitted by smartphone Wi-Fi chipset. Next is mobile phone operating in 900 and 1800 MHz frequency, which is radiating an output power of 2 watts in 900 and 1 watt in 1800 MHz. As we can see from the table, a mobile phone 2G transmitter in 900 MHz spectrum can radiate 40 times the power of a blue LED and 20 times the power of a blue LED when operated on 2G in the 18 MHz spectrum. This is a mobile phone transmitter output power. This is not a base station output power. So a mobile phone can radiate up to 40 times the power of the LED you see in the picture. Next comes 3G technology, which is 0.25 watts, which is around 5 times the power of a blue LED. So we can observe that a 3G transmitter on a mobile phone has less output power compared to 2G transmitter, which is 5 times the power of blue LED. Due to this, 3G technology can be considered as less radiating and more friendly technology. Next is 4G and 5G, which are only 0.2 watts, which is around 4 times the power of the blue LED, which makes it such an attractive technology for gadgets to communicate with base stations. 4G and 5G provide higher throughput, making them more efficient while radiating us with lower intensity. But there is one big downside. Network usage time on 4G and 5G networks increases dramatically due to apps or applications installed and constantly working and refreshing in the background of smartphone operating systems. Due to this, the overall radiation time from smartphone to our body increased and battery life compared to all 2G phones decreased several times. Of course, 70% of battery consumption in modern smartphones come from the CPU and screen time and brightness. But still, the total transmitted power amount per smartphone could be calculated higher than total amount per day for a 2G phone. As in the past, a 2G phone was mainly emitting radiation during a phone call, but modern smartphones radiate during internet activities, which happen every millisecond if the smartphone is active, and every several seconds if the smartphone is on standby. Next, we compare telecom base station carriers or transmitters. They may vary from 10 watts to 40 watts. A 10 watts transmitter could be a base station called a microsite in a dense populated city. These microsites cannot cover large areas. We will see a microsite example in upcoming lesson. Macrosites provide larger coverage areas. Those areas in general have less population. It could be roads between cities, seasides, highways, countrysides. The number of base stations in rural areas is very low. They may look like tall lattice towers with a large sector antennas located at the top of the tower. These base stations can transmit up to 4 times more power per sector antenna compared to microsites. The transmitted power of a base station can be from 200 to 800 times the power of a blue LED, which is quite high for a human body, especially if you are located very close to the base station and at the same height as the base station sector antenna. One more important thing is that the output power mentioned is only for one sector antenna, one frequency and one technology like 2G, 3G, 4G and 5G. When there are multiple technologies on a base station like 2G, 3G, 4G and 5G, each will emit its own transmit signal. So, if we sum up all output powers, we may have up to 200 watts of output power from a base station per sector antenna. A typical base station has 3 sectors. So if we multiply 200 watts by 3 sectors, we get 600 watts of output power. Yeah, a base station with 600 watts of output power may resemble a home microwave oven with the door open, continuously operating on the top of a high tower and transmitting signal in all directions. Why we compare it to a microwave oven? Because the next item in the list is a microwave oven, which typically has an output power of 800 watts or more. And these 800 watts of power is like 16,000 pieces of that blue LED lights. Just imagine 16,000 concurrently operating LEDs. Next lesson, we are going to explore microwave oven components and workarounds to mitigate possible microwave oven radiation. See you in upcoming lesson.